We are continuing with our discussion of sensors and ADCs. We have briefly discussed what sensors are. We have taken a couple of examples. We have discussed a thermistor, we have discussed an LDR, and we have also discussed how these sensors behave, what are their outputs, what's the nature of their outputs, and why we need signal conditioning blocks, and then why we need ADCs to actually interface these sensors with microcontrollers. In this section, we'll be further discussing how the interfacing actually works in real life problems, how a microcontroller can read data from a sensor and then can either display it on an output screen or may take some decisions depending upon the input data, depending upon a changing physical parameter like temperature, pressure, light intensity, velocity, or something else. So let's take a real life example to discuss these things. Let us assume that we have to monitor the temperature of a particular part using a particular machine. We have developed a machine. And then in this machine there's a particular part used. For example, maybe there's a motor which runs continuously and thus generates heat. It heats up. So we have to observe the temperature. We have to continuously monitor the temperature of this motor. We have to monitor the temperature. And then we have to monitor the temperature, and then we have to display it on LCD screen. Fine. Two things: we have to monitor the temperature and then we have to display it on LCD screen. At the same time, there are certain things that we know. For example, first thing we know that the temperature of motor is never less than room temperature. It's never less than, for example, 25 degrees Celsius. Another thing we can assume, or another thing we have to do, maybe something like this: we have to display the temperature on LCD. We will be using a 16x2 LCD. There are two lines and the temperature should be displayed in first line. For example, like this: temp equal to dash dash degree Celsius. Is that fine? Now we might have three different cases. This is the temperature of motor. It can be less than 30 degrees Celsius. Or it can be between 30 degrees Celsius and 40 degrees Celsius, or it can be greater than 40. So accordingly, if the temperature is less than 30 degrees Celsius, in the second line of LCD we have to display a message saying that the temperature is normal. like this, normal. If the temperature is between 30 degrees Celsius and 40 degrees Celsius, we have a different message that needs to be displayed on LCD, and it shows hot. LCD line 2. Line 1, you should again remember, should display a string like this, temperature equal to then the actual temperature in degrees Celsius. And line 2, it has 3 different sections. When the temperature is less than 30 degrees Celsius, it should display normal, and when the temperature is between 30 degree and 40 degrees Celsius, it should display hot, and when the temperature is greater than 40 degrees Celsius, then it should display too hot, turn off. That it should remind the user that the machine is too hot, or a particular part of the machine is too hot and it needs to be turned off. Fine. Then we have another thing, the microcontroller that's monitoring the temperature. That's actually monitoring the temperature. We might have a temperature sensor here, attached to the motor. The temperature sensor might give data to there might be a signal conditioning module, and then it must give data to an ADC, and this ADC will be giving data to the microcontroller. Microcontroller, after processing it, displays it on LCD. There's another thing, there are 2 LEDs connected to this LCD. There's a green LED and then there is a red LED. Is that fine? We have the temperature sensor, it gives data to ADC, ADC gives data to microcontroller. Microcontroller does 2 things, it displays the temperature on the LCD screen, and it also displays a message on the LCD screen. It also has 2 LEDs, green LED and red LEDs. What should happen to these LEDs when the temperature is normal, that is temperature is less than 30 degrees Celsius? Green LED should be on, LED G, I will name the green LED, it should be on, and LED red should be off. And when the temperature is between 30 degrees Celsius and 40 degrees Celsius, that the machine is hot, then LED green should again be on, but this time LED red should be blinking. And in the third condition, when the machine is too hot and we need to turn it off, then LED green should be off and LED red should be on. I will revisit my problem statement. I have a machine, I have designed a machine, there's a particular part, maybe a motor. I need to monitor the temperature of this part of this motor, and then I need to do 2 things. I need to display the temperature on an LCD screen, and I also need to take care of these LEDs. When the machine is working normally, green LED should be on. Then when machine is heating, it is between 30 degrees Celsius and 40 degrees Celsius, red LED should be blinking and green LED should be on. And when the machine is too hot and it needs to be turned off, green LED should turn off and red LED should turn on. Is that okay? Now let's slowly move towards the solution of this problem, how we are going to solve this problem. First we will discuss the hardware interface, and then we will write a program. First things first, the first most important thing is choosing the hardware. We have to choose the hardware. We have to see what type of temperature sensor I will be using, what ADC I will be using, what microcontroller I will be using, what LCD I will be using.